Hello everyone, welcome back to our YouTube channel Gurmantra Shiksha Ka Granth. I am your educator Nidhi Dua and I teach you chemistry for GATE exam. I hope you all are doing good, you all are fit and fine. So without any further delay, let's begin our topic, that is chemistry of group 1 elements. This is our GATE chemistry exam syllabus which is compulsory for all Excel candidates. And these are the topics that we have covered till now. Okay, so before starting our today's topic, chemistry of lighter elements, let's recall the previous video, the previous topic which we have covered. So in the previous lecture, we have studied about the S block elements, particular about the group 1 elements. So let's recall about S block elements. The S block elements of periodic table are those in which the last electron enters the outermost S orbital. The group 1 elements of periodic table consist of lithium, sodium, potassium, rubidium, cesium and francium. As you know, in group 1 elements, francium is the radioactive element with the half-life of 21 minutes. Now we are going to study about the different compounds of group 1 elements, about the chemistry of lighter elements. Number 1 is sodium, that is also known as natrium. So if we talk about sodium, sodium is a chemical element with the symbol Na and it has the atomic number, that is 11. The atomic mass of sodium is 22.98 U, or we can say 23 AMU or U. It is also known as natrium. Its stable isotope is sodium 23. Now if we talk about the extraction of sodium, the process used to extract sodium is Downs process. This is very important to learn that the process used to extract sodium is Downs process. This Downs process consists of the following steps. For the extraction of sodium, you need to electrolyze the NaCl, CaCl2 and NaF. When you electrolyze this NaCl, you will get a cathode in a vessel of iron Na plus n electrons as give Na solid, while at anode the chloride ion dissociate and forms Cl2 plus 2 electrons. In the fusion in the electrolysis of NaCl, CaCl2 and NaF are used because they both as a mixture lower the melting point of NaCl. The actual melting point of NaCl is 800 degrees Celsius. When in the process of electrolysis CaCl2 and NaF is used, then this mixture CaCl2 and NaF lowers the melting point of NaCl to about 600 degrees Celsius. Talking about the properties of NaCl, this sodium or natrium is a crystalline soft metal. This sodium is highly reactive, so this sodium is kept in kerosene or paraffin wax. When you dissolve sodium in liquid NH3, this will give a characteristic color to a solution. That color will be your blue color. You have to learn this point. If we dissolve sodium into NH3, what color we will find? The color will be blue color solution. Now the uses of Na, the uses of natrium. This natrium is used in the preparation of sodium amalgam. As you know, all the members of group 1, all the elements of group 1 shows a reactivity, shows a reaction with amalgam, and this particular sodium amalgam acts as a reducing agent. Next is sodium chloride, that is known as NaCl. Commonly, you know NaCl as table salt. If you talk about the occurrence of NaCl, this NaCl main source is seawater, as seawater is the main source, and also this NaCl is found in salty lakes. Sodium chloride is commonly known as salt, and this is an ionic compound with the chemical formula NaCl and representing a 1:1 ratio of sodium and chloride ions. You have to learn the ratio of sodium and chloride ions, that is 1:1. The preparation of NaCl is the most important term here. If you want to prepare NaCl, you just need to boil, you just need to evaporate the seawater. Seawater with NaCl has 2.7 to 2.9% of NaCl. When you evaporate this seawater, you will get the crude NaCl. This crude NaCl will have some impurities like MgCl2, CaCl2. It contains impurities like Na2SO4, MgCl2, CaCl2, etc. And the impurities which are insoluble are removed by the process of filtration. When you will pass the HCl gas to the filtrate, you will get the pure NaCl precipitation. This is very important that MgCl2 and CaCl2 are more soluble in water, so left in the solution of aqueous solution. Next is the properties of NaCl. As you know, NaCl is commonly known as salt. This table salt is slightly hygroscopic. This is hygroscopic. Hygroscopic means hygroscopic substance is the one that radially attracts water from its surrounding through either absorption or adsorption. Examples included honey, glycerine, ethanol, sodium hydroxide, etc. And this table salt is slightly hygroscopic due to the presence of magnesium and calcium chloride in the small amount. When you react this sodium chloride with AgNO3 silver nitrate, this sodium will displace the silver and forms the formation of NaNO3, and a white precipitate is found in this reaction, that is AgCl, silver chloride. This is very important chromyl chloride test. NaCl shows chromyl chloride test. In the presence of K2Cr2O7 and in the presence of H2SO4, this NaCl is heated, and when you heat this NaCl in presence of these, you will get the NaHSO4, K2SO4 plus CrO2Cl2 plus 3H2O. From this point, a question can be asked, that is, when you mixes NaCl with K2Cr2O7 and 5H2SO4, what would you get? You will get the most important compound, that is CrO2Cl2, and this has the characteristic color, that is orange red. You have to learn the color of this compound CrO2Cl2, that is orange red. Next compound is sodium hydroxide. Sodium hydroxide is also known as caustic soda and is also known as lye. This is an inorganic compound with the formula NaOH. This is white solid ionic compound consisting of sodium ion, Na plus ion and OH minus ions. This NaOH can be manufactured by the electrolysis of NaCl. For this manufacturing, you need two types of cell. Number one is Nilsson cell and also known as diaphragm cell. You need to learn this, that in case of Nilsson cell, the anode is formed of carbon, while In the second cell, Kastner-Kellner cell, the anode is made up of graphite, while in Kastner-Kellner cell, mercury is the cathode, and in case of Nelson cell, cathode is your perforated steel vessel. So these are the important steps which take place in the Nelson cell or diaphragm cell, and in the case of number 2, Kastner-Kellner cell or the Hg cathode process. Next, if we talk about the properties of sodium hydroxide, this is deliquescent white crystalline solid. This NaOH absorbs CO2 from air and forms the Na2CO3 sodium carbonate, and this Na2OH acts as a strong base. When you react NaOH with SiO2 or Al2O3 with the SiO2, this will form Na2SiO3, and with Al2O3 this will form NaAlO2. You need to remember these reactions because they can be asked directly in your exam. Reaction with nonmetals. This NaOH do not shows any reaction with H2N2 and carbon, but with other nonmetals this will show a characteristic reactions, and most important is your boron. NaOH with boron forms a compound that is sodium borate. Reaction with halogens. In case of halogen, NaOH shows two type of reaction, and for reacting with halogen, this NaOH requires the acidic medium. This acidic medium can be of two types. Number 1, the acid could be cold and diluted, and number 2, the acid could be hot and concentrated. With cold and diluted acid, this will form the sodium hypohalite. This is your NaOX, and with hot and concentrated acid, this will form NaOX3, that is sodium halate. Next, this NaOH also reacts with metal, but this NaOH do not shows any reaction with alkyl metals, means with the group 1 metals. When you react this NaOH with other metals, you will find these the compounds are formed, but when the NaOH reacts with metal, H2 gas will liberate. This is very important to remember or learn. The hydroxides of aluminium, zinc, lead and tin, however, dissolve in excess of sodium hydroxide, giving clear solution, which can also be obtained when these metals are acted upon by concentrated solution of sodium hydroxide. This NaOH also shows a characteristic reaction with ZnCl2 or ZnSO4. When this NaOH is reacting with ZnCl2, this will form the formation of ZnOH whole twice, and this ZnOH whole twice will be precipitated down, and when this precipitate is further reacted with NaOH sodium hydroxide, this will form a soluble complex that has the formula Na2ZnOH4. This NaOH is used in the manufacturing of soap, rayon, dyes, paper and drugs, and in the refining of petroleum. Number 4th is sodium bicarbonate. Sodium bicarbonate, commonly known as baking soda or bicarbonate of soda, is a chemical compound with the formula NaHCO3. It is a salt composed of sodium cation and a bicarbonate anion. Sodium bicarbonate is a white solid that is crystalline but often appears as a fine powder. The preparation of sodium bicarbonate is through the Solvay's process. This point is very important, that the preparation of sodium bicarbonate and sodium bicarbonate compound take place with the help of what process? So the correct process is Solvay's process. This. If we talk about the properties of sodium bicarbonate or baking soda, hydrolysis, when NaHCO3 reacts with water, this will form NaOH, sodium, NaOH and bicarbonate ion, and this process is your reversible process. If you talk about the reaction with acids, this sodium bicarbonate ion reacting with acid gives CO2. NaHCO3 plus HCl when reacting will form a salt of NaCl, water, and gives the CO2 gas. But if this NaHCO3 reacts with base, this will give you a sodium carbonate and water, and without the release of carbon dioxide. This sodium bicarbonate or baking soda is used in the preparation of baking powder. In the preparation of effervescent drinks, as you know, this sodium bicarbonate releases CO2 gas. That's why this is used in the preparation of drinks. This is also used in making draughts, and as it includes CO2 gas, this is used in the fire extinguishers. Sodium bicarbonate acts as an anti-acid medicine. This anti-acid medicine is used to remove the acidity. Now I hope you all are cleared about the 4 different types of compounds of group 1 elements. We have studied about sodium bicarbonate, caustic soda, sodium and sodium chloride. Next we are going to study about the anomalous behavior of lithium. Anomalous behavior of lithium means lithium shows some differences with respective group 1 elements. This anomalous behavior of lithium is due to its small size. As you can see here, on account of its small size, it exerts the greatest polarizing effect. If lithium is showing polarizing effect, means the covalent character is developing across the lithium. This lithium has the highest ionization energy and electronegativity as compared to the other alkali metal. And this lithium is not affected by air easily and does not lose its luster even on melting. Lithium is more harder and lighter than other alkali metals. You need to learn all these points because these are the very most important points. This is the anomalous behavior of lithium. This lithium is more harder and lighter than other alkali metals. This lithium is lighter as its atomic number is 3 and its mass is very small or very less. This lithium reacts slowly with water. As you know, in group 1 elements, lithium reacts with steam, while all the group 1 elements reacts with cold water. But this lithium on reacting with steam, on reacting with water, liberates hydrogen. Next, when this lithium is bound in air or oxygen, it forms only monoxide or normal oxide, that is your Li2O. However, the rest of all alkali metals gives peroxide or superoxide. As you know, sodium gives peroxide and the rest will give superoxide. Li2O is much less basic oxide of other alkali metal. If we talk about all the group 1 alkali metals, Li2O is much less basic. Lithium is the only alkali metal which directly reacts with nitrogen to form Li3N. This point is very important. Question have been asked with this point, that which element directly reacts with nitrogen to form this. So the correct answer is lithium. Lithium shows resemblance with magnesium, an element of group 2. And this resemblance is termed as diagonal relationship, which we will discuss in the next video. Now I hope you all are cleared about the Group 1 elements. We have studied the physical properties of Group 1 elements, the chemical properties and the compounds of Group 1 and the anomalous behavior of lithium. Now, in case if you are new here at our YouTube channel Gurmantra Shiksha Ka Granth, please do like, share and subscribe. You can also join our Telegram channel named Gurmantra for more new updates related to your exam. For further queries, please mail us or contact us. The details are given on your screen. Thank you very much guys. I hope you liked the video.